do this problem. Evaluate this double integral. Integral x runs from 0 to 1/2. Y runs from x times the square root 3 to the square root of 1 minus x squared. Now we're in the section of polar coordinates, so let's think about switching everything here to polar coordinates. And there's an arctangent y over x. So you just see that that's going to just convert to theta when we go about. But let's worry about the bounds first. Okay, so x runs from 0 to 1/2. Y runs from x times square root 3 to the square root of 1 minus x squared. So we have here, note that one of the curves is going to be y is equal to the square root of 1 minus x squared. Squaring both sides, y squared is equal to 1 minus x squared. Move that to the other side. X squared plus y squared is equal to 1. So that's part of a circle of radius 1 centered at the origin. Okay, x runs from 0 to 1/2. We know, let's draw here our circle of radius 1. X is going to be 0 to 1/2, so we're in that little strip right in here. And then finally, we need to draw y is equal to x times the square root of 3. If y is equal to x times the square root of 3, note that we have this intersection point here is going to be at 1/2 comma square root 3 over 2. So 1/2 comma square root 3 over 2, that does fall on a circle of radius 1. And that's where x is equal to 1/2. It's coming from that. The upper bound on x there is 1/2. Y is equal to x times square root 3. So this is the region in question. Okay, we need to express this region in terms of theta and r. Okay, so let's see here. Theta is going to run from this theta value to this theta value. The upper theta value is going to be pi over 2. And the lower theta value is going to be this theta value. It's going to be, so you can do it in several different ways. Just realize here that this is y over x is equal to square root 3. What's arctangent of square root 3? That is theta is going to be pi over 3 there for our lower bound. As for r can be anywhere from 0 to 1. So those are really easy bounds. They're constant bounds on both theta and r. This makes our life a lot easier. Okay, so theta runs from pi over 3 to pi over 2. R runs from 0 to 1. Arctangent of y over x is theta times, don't forget the r dr d theta. Let's see here. So to integrate, we end up with, let's see, theta runs from pi over 3 to pi over 2. Theta times, this will give us r squared over 2. Plug in 0 to 1, so that would just be 1/2 times theta over 2 d theta. And when you do this, you'd get theta squared over 4, You end up with, as your final answer, you get 1/4 times pi squared over 4 minus pi squared over 9. And that's our final answer.